Hey guys, my name is Akhil. In this video, I'm going to participate in a virtual contest, bi-weekly contest number 23. It has been already finished in the past. Here we go. So we have 1 hour 30 minutes left. So we'll jump right into the questions. So, okay. First, I'll solve the question and then questions, and then I'll explain it. So we have 1 to n. Okay. Okay, it's accepted now. So basically, in this question, we have an input of integer n, and we have to range from 1 to n, and for each digit, we have to find the sum of all the digits. So we have a collections default it. So what it basically does is for everything that is not there in the dictionary, it has a default of 0. So we range from 1 to n, and there are many possible ways of converting or finding the sum of digits of an integer. So I just converted the integer into a string, and then I have found the sum of all the digits in the integer, and then I've for the particular sum x, sum is the sum of all the digits in the number. I've incremented the value of the dictionary. So it indicates that d of x indicates the number of integers having sum of x, and then we have a maximum size. So we have to return the how many groups have the largest size. So we have to find what is the maximum size. So we have the maximum size collected from the dictionary using the rest size. So now rest size for this example is 2, and so we have the result as 0, and we have to tell how many groups have the length 2. So we have here the I, which will be ranging over the dictionary, and d of I denotes the number of integers having a sum of I, and if that is equal to the rest size that you have previously calculated here, we increment the total result by 1, and finally we return the result, and hence it's accepted now. So we go back to the contest and see the remaining questions now. Construct k palindrome strings. Okay, we have to find palindromic strings using all the characters. Okay, return true if you can use all the characters. So all we have to do is just return true or false based upon if we can use all the characters of the string to generate k palindromic strings, or false if we are not able to generate k strings using all the characters. So this is the key point of solving this question. So we have to be able to use all the characters of the string to create exactly s palindromic strings. Okay, fine. Let's go into the example. So there are many possible ways of creating two palindromic substrings using all the characters here. We can use as mentioned, we can use these two substrings which will definitely be using all of the characters, or we can go with this choice or this choice. So basically first we have to have the okay, so first we need to have the count of each of the characters. So we use a okay, so we have the counter which will store the number of occurrences of each character in the string. So the palindromes can be even palindromes or odd palindromes. So if we have the number of odd palindromes that are greater than the number of, so if we have the number of odd occurrences of a character greater than the total number of required palindromes, that definitely means that we cannot create palindromes using the excess characters. Or we can also think in terms of this: if the number of occurrences of a character is odd, that will result in a unique palindrome. So if the number of unique palindromes exceed k, that means we definitely can't produce a palindrome. right? So using this logic, we try to count the number of odd occurrences. So for I in counter, if so we have this, so it's is equal to 0. If you have the counter of I percentage 2 is equal to 1, this means it's odd. So we obviously increase less equal to 1. And then if the odds is greater than k, return false, else return true. I think this should work. True. Let's see for all. Okay. And one more thing we have to take into consideration is that if we have to create k palindromes but the length of the string is lesser than k, obviously we cannot do that, right? So if the k is greater than length of the s, we have to return false, right? Yes, it's accepted. So we go back. I think this is a quite an intuitive algorithm, but not. It is not very easy to get to the point to realize the fact all this code does. Have a little bit of analysis, and you will finally understand what I finally meant. We go back to the third question. So we have now 1 hour left. Given a circle, so okay, and then an axis aligned rectangle with the coordinates, and on the bottom left corner on the top right corner, return true if the circle and a rectangle are overlapped, otherwise return false. Check if any point xi y belongs to the circle and the rectangle at the same time. Okay, what they ask is they give the center and radius of a circle, and also the bottom left and the top right corner of a rectangle, and the rectangle is always like this, so basically we don't have any problem with the arrangement. Okay, so what we should return either true or false for the overlapping of the circle and the rectangle. So we'll go back to the normal mode, we'll reset it. Okay, so first let me code this up so I can explain it in detail. So when we think about this, there are basically few cases to consider. As mentioned, yeah, this is the case. The circle can be completely inside of the rectangle. That means the center should be within the center of the circle should be uh, in the range of this bottom left coordinate and this uh, top right coordinate. So when how to find whether a circle's center is in the boundaries of this. So you have this and this coordinate, you can easily guess this coordinate as -3. So if this one is x1 y1 and this two is x2 y2, this should be definitely at the height of y1, and the x coordinate will be equal to 3, and obviously this should be derived similar to that, and the x coordinate will be obviously the x1 and the y yes, the x coordinate will be x1 and the y coordinate will be this y2. From this we can say if the x1 y1 is within this boundary. So So the center of the circle, let us say it is x and y, and this one is x1 y1 and this one is x2 y2. So this should we derive all the coordinates, and then okay, so the x should be in between x1 and x2, and the y coordinate should be in between y1 and y2, and y1 is this and the y2 is this. So the coordinate of the center should be between the x boundaries of these two coordinates and the y boundaries of these two coordinates. So basically from this one case will be covered, and then the other case will be intersection on this direction, intersection on this direction, intersection or overlapping on in this edge, I'm sorry, it's an edge, and on this edge as well. So we have the four cases. Intersection on this edge should be defined by the radius. So if there is an intersection here in this region, so if we find the radius, the distance between, so from every point from here to here, for all the points, the distance from that to the center of the circle should be less than or equal to the radius of the circle. That means it is obviously intersecting here. And then to determine whether the circle is intersecting here, we just have to consider the same way. Consider all the points from here to here, increment by 1, and just see if the random xy point and the xy coordinate are less than or equal to the radius. So doing that on all four directions and testing the center to be in the boundaries of the rectangle determines obviously returns true, and all other cases return false. So that is the ideology, and we will start coding it up. Okay, so first we have to see with the circle inside of it. So let's just rename it for simplicity's sake. XCYC. Okay, so what we have to do, X center, Y center. Okay. Okay. So this is the case, the first case we have talked about. So now we have all the points on all the four sides. So for x1 to x2 plus 1. So for all the points from here, all over here to here, we just have to, the x is this and the y will be always y1. X is equal to x and y will be y1. So, and we have to find the distance between xc, yc, center, and the x and y. If the distance is less than or equal to radius, so okay, if this is less than or equal to radius, return true. And again y is equal to y2, and y is equal to y2 is for this edge, the top edge. So we range over from x1 to x2, and y is always y2 at this level. If distance of xc and yc and x and y is less than or equal to radius, return true. So similarly we just cover the remaining two, this one. remaining two sides, y1 and y2 plus 1. X is equal to x1 if distance of xc, yc and x and y is less than or equal to radius, return true. And then now this one, x is equal to x2 and then distance of xc, yc, x and y is less than or equal to radius, return true. So now we have to define the function distance. We'll just do that. Distance of a1, a2, b1 and b2. B1, b2, b2. And return a1 minus a2 whole square plus b1 minus b2 whole square. So since we are not doing the square root, we just have to do the radius square everywhere. So now it makes sense just to return false if none of these conditions satisfy. We'll just go ahead and do that. This is a syntax error. Might be missing something here. Okay. We'll try to run it again. So now we have got true. We'll try submitting this. Okay, done. So remembering all the cases to solve this question is very crucial before coming up right up to the solution. Okay, that's it for this question, and we'll jump to the last question. Choosing dishes. Okay, so we have the satisfaction level. Okay, so we have an array of satisfaction. Satisfaction of I denotes the satisfaction, as I said. So we have n dishes, and to cook each dish they take one, and the chef takes 1 unit of time. And with consecutive dishes, like if he starts with this dish, the time will be 1, and then if he goes till -8, it is time 2, 0 it's time 3, time 4 and time 5. So as mentioned, it can be any order, so we should get the maximum value of time of I into satisfaction of I. So the time of I will not be according to the I, it is just the number. I mean, it is not dependent on the index. You should consider the nth dish. Suppose he is taking the -1 and then leaving -8 and then taking 0. So we should consider time here as 2, not as 3. Okay, with that said, we'll try to do that. So in my opinion, dynamic programming will help a lot, because we have to check all the possible permutations, all the possible sequences, and return the maximum one. We'll just go ahead and reset this. So we want a maximum satisfaction. So this will be possible if we start, when we have the highest time, you should be doing the dish with the maximum amount of satisfaction. So that means it should be in sorted order. So by the time you take the dish with the highest amount of satisfaction, the time will be also the highest. As a whole, it results in a maximum. So it increases the chances of getting to the maximum. So we'll just sort this. After sorting, all we have to do is going in order, and so for every dish we might consider this dish or not. So for every dish there are two possible chances: either you consider the dish or you don't consider the dish. Keeping that in mind, so we'll create a function with maybe idx index for, we don't know whether we take this or not. So if the idx is crossing n, we just have to return zero satisfaction. Or take if you take the dish, you mean to have, okay, we also have to consider the time, right? So if you take the dish, you just have to take satisfaction of idx into time. That's it. And we also have to parse the remaining array, idx plus 1. And since you have taken the dish, the time also has to be incremented by 1. And the other choice is you don't take the dish. So in this case, you just go to the next element without considering this, and the time will also be remaining the same. So in this way, we have to return which one is the maximum. So since I've said the dynamic programming, so this is a pure recursion, and to eliminate the redundancies, to eliminate the repetition of the same subproblems, we just use the dynamic programming. So that's it. And so we just use 0, and the time will also be so it should be 1, right? So it should start with 1. Okay, we'll see if this is, n is undefined. And okay, so I think this should be the first case. So okay, we got the solution. Okay, we'll submit this. Yeah, that's it. So here the main ideology is to think that for every dish we either take the dish or not. If we take the dish, we have to increment the time by 1 and pass it on to the remaining elements. And if we cross the n, that means if you try to attempt to cross the array, we just have to return 1 as there will be no sum after that. So that's it, guys. That's it for this video. I think we have covered all the 4 problems of this bi-weekly contest 23. That's it. If you want to watch more videos, subscribe to the channel. Thank you so much for watching, and thank you. See you.